Well, OH or OR group. It may be OR or OH. As we know, it is ortho and para directing. We can explain that based on the resonance, there is momentum, electron pair, and also the pi bond. So this electron move here, oxygen carry positive charge, here we have a double bond. This pi electron move to this carbon, so we have to write negative charge. The remaining bonds are not affected. That means we have the negative charge or electrophilic center at ortho position. We can write few more resonance structure for anisole or aromatic ether. So it's a double bond OCH3. We have a positive charge. Now this electron, pair of electron, that is a pi bonded electron, move between these two carbon atoms, and this electron pair move to this carbon. So we have negative charge on this and double bond due to the movement of this electron pair between these two carbons. The remaining bonds are not affected. This electron move here and pair of electron, pi electron on that carbon. So we have negative charge on this carbon, double bond O plus, then we have CH3, double bond here, double bond here. Now again there is movement of this electron pair between this between this carbon. We have double bond here and double bond here. At the same time, there is a movement of this electron on the oxygen. So we have electron pair, double bond, exchange into single bond, CH3. Well, this indicates that we have the negative charge on ortho and para position. So these are the ortho position, means adjacent carbon to this carbon, ortho position, and we know this is called para position. So you are getting ortho and para products when the anisole or aromatic ether undergo electrophilic substitution reaction. The attacking reagent attached to the ortho and para positions are getting ortho and para product. Well, already we have studied about bromination of anisole. That bromination takes place in ethanoic acid. That means ethanoic acid or acetic acid is the solvent, and you are getting ortho and para products. Now next reaction is, it is the second reaction, second electrophilic substitution reaction. Well, it is nitration. Well, we know nitration generally carried out by using concentrated HNO3 in presence of concentrated H2SO4. For example, we are studied in PUC first year, nitration of benzene that takes place in presence of concentrated H2SO4. It is not necessary to use it's only HNO3. We can also use potassium nitrate or sodium nitrate. They produce HNO3, then attack on the benzene ring takes place. What's the use of this H2SO4? H2SO4 helps to produce NO2 plus nitronium ion. Electrophile nitronium ion is formed in the presence of H2SO4. and that nitronium ion attack on the electrophilic center. Here is ortho and para. So you are getting ortho and para product. Well, nitration. Anisole undergo nitration. Anisole undergo nitration when heated with concentrated HNO3 in presence of concentrated H2SO4 to give orthonitro-anisole and para-nitro-anisole. Orthonitro-anisole and para-nitro-anisole. Orthonitro-anisole and para-nitro-anisole. So question is, OR means OCH3, it is, we know, anisole, or it is methoxybenzene according to IUPAC system, plus HNO3 in presence of concentrated H2SO4, both are concentrated. So the product is orthonitro-anisole and para-nitro-anisole. OCH3, then NO2, it's orthonitro-anisole, and one more is para-nitro-anisole. OCH3, we have NO2, para-nitro-anisole, and H2. So it is 2 times, here you have to write 2 times. Well, you write the name of this one, orthonitro-anisole, and one more is here para-nitro-anisole. Well, afterwards, we have next reaction, Penols reaction. As we know, Penols reaction means you are using anhydrous aluminum chloride as a catalyst. Remember this point. Whenever the question of matching comes for the competitive examination, when we have on one side Penols reaction and on another side, if you have many options, if AlCl3 is given, remember you have to mark to AlCl3. So anhydrous aluminum chloride is used as catalyst in Penols reaction. Here we have 2 types of reaction. One is alkylation and another is acylation. So in alkylation, as we know, you are using alkyl halide like alkyl chloride or alkyl bromide. Then acylation, we know you are using acetyl chloride. So in Penols reaction, we have 2 reactions. I am writing A. One is alkylation. Well, for example, I am writing this methylation. Anisole undergo alkylation. I am writing here methylation, in the bracket I am writing methylation with methyl chloride. We know the formula C3Cl in presence of in presence of N-nitrous AlCl3 to give ortho-methyl anisole and para-methyl anisole. Para-methyl anisole. So, question is ortho-nitroanisole and para-nitroanisole reactant is anisole OCH3, then CH3Cl, so 2 times. Here also we have 2 because we have 2 products ortho and para in presence of AlCl3. Product is ortho nitroanisole and para-nitroanisole. Para-nitroanisole. Sorry, ortho-methyl anisole and para-methyl anisole plus Cl. So write the correct formula. So ortho-methyl anisole. Instead of methyl, the question may be ethyl also. Anisole, then you have to write ethyl as the product, ortho-ethyl anisole, like that. Depends on what type of alkyl halide you are using. Then para-methyl anisole. Para-methyl anisole. So this is alkylation. Afterwards, we have acylation. So I am writing acylation. Second one, acylation. Or I can write in the bracket. Now the good example for acylation is acetylation. 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 Well, anisole react with acetyl chloride. Anisole react with acetyl chloride. Acetyl chloride in presence of N-nitrous AlCl3, N-nitrous AlCl3 to give ortho-methoxy acetophenone and para-methoxy acetophenone. So question is, it is anisole or it is methoxy benzene. It is anisole or we know according to IUPAC methoxy benzene. When treated with acetyl chloride CH3COC, product are ortho and para. So reaction takes place in presence of AlCl3. Ortho and para are the product. OCH3, as we know, The acyl group is RCO. Acetyl group is CH3CO. Here R is CH3. The product is COCH3. And one more is OCH3, then COCH3, well, one more is C. Anisole. Well, to name this compound, you are giving reference to the functional group CO. That means it is acetophenone. This is called acetophenone. Which one? This one is called acetophenone. So this is acetophenone. Well, here one nitrogen is replaced by OCH3. So it is methoxyacetophenone. At para position, so it is para-methoxyacetophenone or orthomethoxyacetophenone. So this one is orthomethoxyacetophenone, and one more is para-methoxyacetophenone. So remember the name of the product. Well, in all these electrophilic substitution reaction, you are getting two products. It's ortho and para. Now question arises, which one is the major product? Whether ortho product is the major or para product is the major? Well, simple answer is it is para. Why it is so? This is because attacking reagent, if it is at ortho position, that means here there is a greater repulsion between this reagent, attacking reagent or CH3 group and OCH3. Due to repulsion, the attacking, the portion, I mean the extent of attaching to this carbon become less because it repels. Repulsion become minimum when it is at para position in opposite direction. There is no repulsion at all. You may say here, this is above the benzene ring and this one is below the benzene ring. So para product is major and compared to this ortho product in all these reactions, all electrophilic substitution reaction, electrophilic substitution reaction, para product is major. Para product is major, then ortho product. So what you have to remember is, in electrophilic substitution reaction, which is the major? Rare question it is. It is common sense. It is the para product only due to less repulsion between the attacking reagent and the group present on the benzene ring. It may be anisole, it may be phenol, or it may be some other aromatic compound. Always remember, para product is the greater compared to ortho product. Well, this completes the organic compounds containing oxygen part 1. So here you can expect around 7 marks from this topic. 7 marks means it is around 4 marks, 3 to 4 marks from the first subtopic, it is alcohols, then remaining it is 3 to 4 marks from the remaining phenols and ethers. Well, in all these topics, remember the important one is dehydration of alcohol, acid catalyzed dehydration of alcohols. You practice many times, it's important. Even other portion also important, but usually you can refer the old question paper. That question repeats many times. So should be perfect in acid catalyzed dehydration of alcohol. We have 3 steps, and I already told, try to, you must remember, not try, you must remember the position of the plus charge, that is on which atom you have to write a plus charge. So first one is protonation of alcohol, there you have to write plus charge on the oxygen atom. Second, formation of carbocation, there you have to write the plus charge on the carbon. 2 carbon we have in case of ethyl alcohol, on the CH2 carbon you have to write plus charge. And third one, elimination, there is no charge formed in the final product, that is in ethene. So writing the charge and writing the correct formula of the reactants and product is also important. For example, in case of last step, elimination of proton, when the proton get eliminated, you have to write H plus. Without H plus you won't get a mass. You must perfect in the mechanism. Even other portion also important. In the alcohols, important one is preparation of different types of alcohols. You may have a question for the board exam or maybe for the competitive exam. You must be perfect in the preparation of primary alcohol, secondary alcohol and tertiary alcohol by using different reagents. Already you have studied, it is from ethene, it is from carbonyl compounds, that's aldehydes and ketones, and it is from the Grignard reagent. So all these reactions are important. And afterwards in properties, it's a reaction involving cleavage of OH bond. There we have to discuss reaction with sodium. Then it's esterification with the carboxylic acid in presence of concentrated H2SO4. Then acylation, and afterwards reaction with acetic anhydride. So all these the reactions are important. Afterwards, we have studied oxidation of primary alcohol, secondary alcohol and tertiary alcohol. Then we have studied dehydration of alcohols. So in dehydration of alcohols, it's a primary, secondary and tertiary. Also you have to remember the reactivity order of all these dehydration of alcohols. That's also important from the point of competitive examination, reactivity order. And then next we have studied dehydrogenation of alcohols. For the oxidation, which reagent you are using, you have to remember. For the primary alcohol, which reagent, secondary alcohol, which reagent, tertiary alcohol, which reagent. And then we have a question from the dehydrogenation. Which catalyst you are using for dehydrogenation and what temperature you have to maintain dehydrogenation, that you have to remember. Otherwise, without writing the catalyst or without specifying the temperature, you may not get a mass. You are losing the mass during the, in the reaction dehydrogenation of primary and secondary alcohol. As we know, tertiary alcohol do not undergo dehydrogenation, it undergo dehydration. So all these points you have to remember while studying. Just you write the things, means preparation. Just you have to write preparation by different methods. Okay, just you have to write, for example, from alkene. You can see the notebook from alkene. Two methods are there. One is acid catalyzed hydration and second one is hydroboration oxidation. Only heading you have to write, remaining you have to complete. And afterwards, from carbonyl compounds, primary alcohol, secondary alcohol and tertiary alcohol, what type of reagent you are using, that you have to remember. Whether you are using aldehyde, ketones or carboxylic acid, and what are the conditions to add the hydrogen into the carbonyl group, that you have to remember. And then it is by using Grignard reagent. So by using Grignard reagent, which type of reagent you are using to get aldehyde, which type of reagent you are using to get the your secondary alcohol, which type of reagent you are using to get the tertiary alcohol. These points you have to remember. Practice it. And then in the properties, just I told, acidic property, it involves the cleavage of OH bond. So which of this reaction may be in competitive examination, which of this reaction involve the cleavage of OH bond. Then there its mechanism is important, that's a dehydration mechanism. Afterwards oxidation reaction, sometimes it may comes for the 1 mark in the board exam, and these questions are common. That's oxidation, what type of reagent you are using, what's the product formed. This type of questions are common for the competitive examination, when CT or some NEET, JEE, etc. So you must be perfect in all this. Afterwards in phenols, it's a preparation of phenols by, I think I have given the 3 methods, it's there for the syllabus, 3 method only. One is from benzene, 4 methods are there. One is from benzene, then it's from chlorobenzene, then it is from BDC, benzene diazenyl chloride, and one more is from cumin. All these reactions are important. You have to remember the formula of cumin and what are the steps involved in the reaction. Why the cumin reaction is important from cumin? This is because you are getting one more product, that is a stone, as a byproduct. That the chemical is also important. A stone is used as a solvent and also for the production of some in a pharmaceutical company you are using a stone and also as a solvent. And afterwards the properties of phenols, reactions involving again cleavage of OH bond, that's the acidic property, reaction with the sodium, reaction with NaOH. So in this case it forms a salt, and then after reaction with the NaOH and OH, you have to show the acidic strength of phenol, comparison of acidic strength of phenol with the substituted phenols, like there is electron dominating group and electron withdrawing group, nitrophenols and cresols, just to compare the acidic strength with the cresols and phenols, or nitrophenols and phenols and cresols. I have already given that. Okay. Afterwards, it's reactions of phenol. Just I told, one is the cleavage of OH bond. Again we have a cleavage of OH bond with the esterification with H2 in presence of some acid. Then acylation. Then with the acetic anhydride. The acetic anhydride, you have to remember, you are using phenol derivatives. That phenol derivatives is salicylic acid. In salicylic acid, when you are using, you are getting a aspirin. Well, we have 2 OH group in salicylic acid. One is the phenolic OH group and another is carboxylic OH group. And remember which OH group involved in the reaction. It is a phenolic OH group, not a carboxylic OH group. So just by treating salicylic acid with acetic anhydride in presence of concentrated H2SO for 2 drops, no need of using excess. You can prepare in the laboratory also. The product is aspirin. Well, afterwards it's in reactions of phenols, oxidation of phenol. Oxidation of phenol use the benzoquinone. So it's a dark in color, dark brown color. The dark brown color benzoquinone is also formed when phenol is exposed to air. So the color of phenol changes to brown. And again we have the elimination of phenolic group. Phenolic group can be eliminated by using Zn dust. When phenol is heated with zinc dust, you are getting the product benzene. So remember this point also. Phenolic group can be eliminated or removed by using Zn. This point is important. For example, suppose if you are given the formula of like salicylic acid. So if you want to get the benzoic acid, you have to heat the salicylic acid with Zn. And we know if you want to remove the carboxylic group, you have to heat with the sodium. You have to heat with the decarboxylating agent soda lime. It's a mixture of NaOH and CO. So that all these points are important. and then it's electrophilic substitution reaction, getting the picric acid concentrated or forming HNO